This is the screencast for section 3.3, example 5. We're now going to learn the quotient rule. When you have two functions that are in a quotient, so one divided by another one, you have to learn this rule today, never forget it, to differentiate the quotient of those two functions. You will take v, which stands for the denominator, and multiply by the derivative of u in the numerator, then subtract u, which is the numerator by itself, times the derivative of the denominator, v, and then divide all over v, the denominator squared. So shorthand, it looks like this. Now in product rule, it didn't matter so much which one you took the derivative of first, but now that that subtraction sign is here, you have to take the derivative of u prime first. So what I remember is that v squared here in the denominator also goes first, so you should see the same thing both in the denominator and up here, and then take the derivative of u prime. That's how I remember it. So example 5 asks us to differentiate this quotient and then support it graphically. So we will. F prime of x equals, so here's my denominator that I'm going to see first up in the numerator, x squared plus 1. Now the derivative of u, so u prime, is just going to be 2x minus, now u, the numerator, before it was the derivative was taken of it, was x squared minus 1. And then v prime, the derivative of the denominator, is 2x. All over, now the denominator squared, so that's x squared plus 1 squared. Now that's a mess. You are more than welcome to multiply it all out, but you do not have to unless it's a multiple choice question. However, it does say support this graphically, so that's what I'm going to do. I'm going to put in y1 the original function, but I'm going to turn that off. I'm not going to graph it. In y2, I am going to graph f prime of x, or my answer. In y3, I'm going to tell the calculator, take the derivative of what's in y1 and graph it bold. And then what I did is I saw, here's what I graphed in y2, and then in bold, it graphed right over the top of it so I can make sure that my graph was the same as what the calculator says the derivative should be. So there's a better look at what I had in my calculator. The Now Try problem number 19 asks us to find dy dx and support our answer graphically. Well, this becomes a little bit more complicated because we have a product in the numerator of the quotient rule. So I have definitely a numerator over a denominator, but within that numerator I have another u and a v. So essentially my y prime, dy dx, is going to equal, and I'm just going to shorthand this so that you can see how this is playing out. I'm going to have the denominator first times the derivative of the numerator minus, now I'm going to leave the numerator alone, times the derivative of the denominator all over the denominator squared. Now you in no way can write this out. This is not showing your work. This is just my shorthand to show you what I'm going to do for notes purposes only. So that means dy dx would equal, okay, the denominator, which we'll call w times, now the derivative of the numerator is going to be u times v prime plus v times u prime. Then we're going to subtract the numerator by itself, so u times v, and then times the denominator, the derivative of the denominator, all over the denominator squared. Whew! Did you follow that? So we have the quotient rule, but embedded in the quotient rule is a little bit of product rule to find the derivative of the numerator. Now what if I told you there was a much easier way to do this? Remember a couple examples ago when I said sometimes it's a little bit easier just to do some algebra up front? So what I'm going to do as my very first step is algebra. I'm going to multiply out x minus 1 times x squared plus x plus 1 in the numerator. Combine like terms. And now I have something that is very easy to use the quotient rule on, so that is what I will do. Quotient rule says I'm going to see the denominator first times the derivative of the numerator minus, now vice versa, the numerator times the derivative of the denominator, all over the denominator squared. And if you want to simplify that out a little bit, you can. So depending on how far you take this and how you want to leave your final answer, I got 3 over x to the fourth or 3x to the negative fourth. So let's see if that graphs correctly. And as you can see, I put the original in y1, I put my derivative that I found in y2, and then I told the calculator to take the derivative in y3 in bold. And I find that my derivative and the calculator's derivative have exactly the same graph, so I did it right.